we're in the office here in Heiko again today, making another video, letting you get to know your farmers a little better and your beef sources. We're celebrating today a little bit. We've got a lot of subscribers on our YouTube channel, and happy to see the success we've been having there. So if you're a follower and watch us, then subscribe and help our business grow by doing that. Today in this video, I wanted to kind of talk about some questions I've received. It's always interesting working with an urban market like Las Vegas and advertising our beef product to Las Vegas, and then responding every day to all the questions that we get. They're very wide ranging in the topic and the interest that people have and the concerns they have about their food. But today, just because I've had several people ask me over the last couple of weeks as we've been marketing beef, they've been asking me about carbon and are our beef carbon friendly, or some regard like minimalize the carbon footprint. Some have asked me about methane and the cows being bad for the environment, and I think people pick up all that information from news and other social media feeds with maybe not understanding exactly how that relates to agriculture and what we're doing here on the farm. Basically, I would like to talk to it today about it on the most simple chemical and biological and cellular levels that there are, so that people can understand what we're talking about when we're actually talking about if our cows are carbon neutral or not, or carbon friendly. Basically, in life, what we're trying to do when we talk about carbon is pull carbon dioxide out of the air and fix it in a form that it's not a greenhouse gas. So we put it into some sort of a form where it's locked up and it's solid. And so as farmers, we think that we're pretty good for the environment because we're growing plants. And as the plants grow, photosynthesis happens, and the plants take carbon dioxide and water, and then the energy from sunlight and through the chlorophyll process, they fix that into sugars. And the most common sugar from plants is glucose. And another one that people like a lot is fructose, or fructose as sometimes it's called. And then if you have a combination of those two, then you can make sucrose. And so those are all chemical formulas that are, I have a little cheat sheet for you, C6H12O6. And so those combinations, there's carbon, hydrogen, and oxygen, and the plant can fix those elements out of the air and put them into a carbon form that's sugar. Now, a plant's the only thing that can do that in the world, and that's why when we always talk about carbon banking and other things, farmers become involved. Big carbon fixers in the world are either phytoplanktons in the oceans, the Amazon rainforest, or the American Corn Belt. If you talk about farmers in the United States, the corn and the agriculture in the United States is one of the largest carbon fixing entities there are, just because of the productivity of the agriculture. Okay, so we're going to bring that back to cows then. Out here in the Nevada desert, our cows are out on the range and they eat the grass that grows out there. And that grass has about, that it's made from carbon. The cellulose and the glucose that's in the grass is something that people can't generally use. We can't eat it and digest it, but cows can, because cows have a rumen, a big old fermentation vat in their stomach that's full of microbes, and those microbes can eat the cellulose and eat the sugar, and they can break it down into small digestible particles that the cows can use to build protein out of. Now, humans, other animals, they don't have this ability to convert forage into protein like a cow can. And so in this process, the cows sometimes give off methane that come from the microbes in their belly that is digesting the food and breaking it down. But if you think about the grass itself and the brush and the things that cows eat out in the open, they can only go away in two ways, either through combustion and fire or through cellular respiration, which meaning any organism that eats it, from a person to a cow to a dog, cat, any of it, breaks it down and digests it until it gets into the cellular level. And then we reverse that process of how the sugar was built by putting the carbon and the water molecules together. Then we take oxygen and water and we separate those back out. Again, I'll show you a little cheat sheet, which is cellular respiration here. But you take the sugar molecule, you add oxygen, and then you separate that back out, where the cell of the animal or any organism that eats it is getting energy out of that. But then the byproducts, again, are carbon dioxide and water. So as we live and breathe, the reason we need oxygen is for that cellular thing to happen. Okay, so I know this is 7th grade science again, but I just want you to focus on it in the agricultural world or the cow world on that cellular level. And know that the cow then, and I won't teach you a big lesson on how these carbon chains of cellulose and glucose are converted into protein, but in the beef world, our cows are their DNA is efficient at making these grasses and forages into beef. So they can take all this and convert it into a protein at the rate of 2 or 3 pounds per day. Now, if it was a dairy cow, that cow is genetically programmed to convert what she eats and put it into milk proteins. Okay, so people are going to still take, tremendous amount of pounds of milk away from that cow every day, because she has taken these carbon fixed plants and converting it into a milk product that then people can use. And so my point here is that cows are very efficient in taking things that other animals can't digest in cellulose and these carbon chains that are built in a very complex manner, and they can convert them into a usable protein source like milk or beef in a very efficient way. And so if we take this cow and she is eating a tremendous amount of grass and brush and forage every day, and the mama cow is making milk for her calf, and he's getting proteins, and he's also eating grass, and his rumen's starting to work, and so he's digesting stuff. That calf is growing at about 2 pounds a day until he reaches 6 months of age. And then after that, he's going to grow at a rate of 3 to 3.5 pounds a day if he has enough feed inputs to do that. And so I guess my point there is that cattle are converting at a high rate, and you're locking all that carbon up in protein, which to me is very carbon friendly. Now we can talk about how many machines we use and how much diesel we burn and all of the different things that expel stuff back into the atmosphere as far as combusted carbon. But here at High Kohen Cattle, my opinion again is that our cattle are very carbon friendly because they're not trucked all over the country. They're not transported long distances because all of the farming is done here. The majority of all the forage crops are grown right here on the farm. And for the most of their life, they're out in the desert foraging and gathering up those grasses on their own and converting them into that protein source. So there's lesson 1 on carbon.